I'm gonna name Schmidt. That's what. Or. There's Schmidt.
Okay, the homework tonight is this packet. As always, there are answers in the back to make sure you know you're doing it right. As always, we joke about this, but it's really a serious problem for some people. Do not do your homework like this. I'm not sure. Oh yeah, that makes sense. Did you write it down? Like, just put it here. Don't do that. The point of the answers are to simply verify that your logic is correct. If you are using the answers to do more than verify, you're in trouble. Like if you try to use the answer to try and figure it out, you usually end up doing very poorly on a test. So you can't figure it out first and then just check the answer. You've got to come talk to me. So today we're going to talk all about this, and then this is the homework. Okay? Now, this packet is a combination of concepts. Some of the concepts in the packet are things you've already learned, so nothing really new, just trying to get you to tie it together. We're getting really close to the point in the year when we practice everything simultaneously. So we just start getting everything merged. There's one new idea here. When we get to it, I'll talk about it. Okay? So starting at the very beginning, it says extra examples. These are a few problems I put into the packet. There are no answers for the ones that are labeled extra example. So we do those together in class first. Okay? This has the standard FRQ format. There's a table. They give a description. It says the rate at which water flows out of a pipe in gallons per hour. Okay, as we start working on the entire year's worth of ideas, Danica's chart repeatedly becomes very helpful. For example, as I'm reading this problem, one thing I might do is say, okay, wait a minute. They're giving me a rate, gallons per hour. That means there is some amount to go there. I'm in this column here, gallons per hour. And they told me this is R of T. But that means there would be a third column, which would be gallons per hour squared, or gallons per hour, and that would be R prime. So that's my Danica's chart for this situation. Please.
How did you get the gallons per hour squared?
So that comes from the fact that if I have this, and I'm taking a derivative of this, I'm finding a rate at which this changes. So that would be gallons per hour, because this is the rate at which this rate is changing. So it's like this is changing by so many gallons per hour every hour. If you do the math on this, you have one fraction divided by another fraction. But dividing by a fraction is the same as multiplying by the fraction's reciprocals. So you get that. That's where you get gallons per hour squared. Points for Elijah. Anybody else? So this is a rate. This is an amount. This is a rate of a rate. Question. Awesome. Okay, so that's what they're describing. And here's the question. Use the data in the table to find an approximation. As always, you have to read really slow. So I'm approximating something. Approximating R prime of 12. So I'm supposed to take R. So Danica's chart, I'm supposed to start in this column. It's supposed to find an approximation for this. which means I'm supposed to take r and find the derivative of r. Or you can think of it as I'm supposed to start with r and find the instantaneous rate of change of r. So I'm trying to find r prime. Or you can think of it as I'm supposed to take r and find the tangent slope of r. That's what r prime would mean. You don't need me to repeat any of those. They all mean the same thing, we just have to do that. Okay, so r prime of 12. Well, you need to have memorized, I've said it before, we're supposed to find, this means tangent slope of r, but we approximate a tangent slope of r by finding a nearest secant slope of r. If you don't have that already memorized, I would create a flashcard. You approximate a tangent slope of something, r, whatever, by finding the nearest secant slope of r. That must be memorized. It will happen on the test for sure. So you approximate, we'll just use r as an example, Maya. You approximate the tangent slope of r, because they're giving us r and they want the tangent slope of r. That's what r prime means. We approximate a tangent slope of r by finding the secant, nearest secant of r. Another way to say it that you should memorize as well, you approximate an instantaneous rate of change by finding a average rate of change. You approximate an instantaneous rate of change by finding an average rate of change. Questions? Maybe you need to repeat any of that. Let you catch up in your notes. Brendan, question though.
What was the second one?
So you approximate an instantaneous rate of change, because right here, Avery, r prime means the instantaneous rate at which r is changing at time equal 12. So we're going to approximate that instantaneous rate of change by finding an average rate of change. Because tangent slope means instantaneous rate of change, secant slope means average rate of change. It ties back to the mean value theorem as well. We tested on before Christmas. Mean value theorem is where we say, hey, an instantaneous rate of change is equivalent to the average rate of change is equivalent to one of the instantaneous rates of change. 2 points for Avery. Anybody else?
Where you approximate the instantaneous rate of change by finding the nearest average rate of change?
Perfect. Which means exactly the same thing as you approximate the tangent slope by finding the nearest secant slope.
Okay.
So I say it to you 2 different ways because they'll test you on both methods and both wordings. Does that make sense? 2 points for Rachel. Anybody else? Awesome. So I write down that r prime of 12 is approximately, I find a near secant slope. This one's fine. So I say 11.4, subtract 11.2. That's the change in the output divided by the change in the input. 12 subtract 9. You would need me to talk more about that. Please.
So why did you choose the 11.2 instead of the 11.3?
Awesome. 2 points for Elijah. So you put on your flashcard that we're going to approximate the instantaneous rate of change by finding the nearest average rate of change. And Elijah's correct. I chose to go between 9 and 12 because I need to find what's happening at 12. I could have gone between 12 and 15. I get a different result, but on the AP test they would give me full credit. Either one is accepted. It doesn't matter which one you pick. Either one would be fine. Please, Zach.
So is it never acceptable to do like 9 and 15? 15 along the opposite end?
So 2 points for Zach. That also is legal. They don't really have a preference as to which one you use. So I could have done 11.3, subtract 11.2. They're all different approximations, But because it's an approximation, all are considered valid. It's perfect. Anybody else? 2 for Zach. Elijah will explain what I mean by the 2-point thing. So, okay, cool. Back to Zach's question. This is highly unusual. This test was given in 1999. Since that time, I don't recall them ever giving you a problem where you could do it one of 3 ways. I kind of just suspect they got tired of grading 3 different possible methods. So the more recent tests, they have asked questions like, find an approximation for r prime of 20. And because 20 is not in the table, there really is only one choice, and that's to find the secant slope from here to here. So the concept doesn't change. You're still finding the nearest secant slope, but there's only one choice, really.
If 15 was like 16 hours, would you go with the 9 and 12 because that's closer to 12?
I would, for sure. Although they never tested that kind of subtlety, but that's what I would have done. 2 points. Anybody else? Awesome. Next one. Excuse me. So just to make sure it's making sense, everybody do that one for me. Joe, stop me if you have a question. So just do the next example. Because it's the written portion of the AP test, you do not have to do any what's called numeric simplification. So you actually don't have to work this out on your calculator. You can leave it as I've written it. You do have to write the units or you lose a point. So what I have written on the board would be worth 2 points. 1 point for showing the computations correctly, that's this. 1 point for the correct units. Please, Alice.
On the units, will they accept gallons per hour squared?
Either way, 2 points. Anybody else? Please.
Sorry, I just
No,
was
you're good.
thinking, how do you get to the fractions again on the...
Oh, no worries. Alpha F1. Points for Brennan. Anybody else?
So you don't actually have to do this stuff on the calculator.
Just write it down. Just leave it like that. Yeah, just it's safer anyway because then you don't accidentally make a mistake. So full credit. Questions here? Awesome. Okay, next thing. Turn the page. Okay, on this page, eyes on me, everybody. Everybody, look at me. Okay, on this page, I'm going to give you kind of an explanation, and then I will show you what you would actually do to get the points on the AP test. So the first part of what I'm talking to you about is not how I solve the problem. The first part I'm talking to you about is helping you understand the meaning behind the problem. Okay? As always, if you can make sense of what I talk about in the next few minutes, then actually solving it becomes easier. But what I'm about to write on the board, you do not write what I'm about to write on the AP test. This is just me explaining the underlying concept. Any questions? Okay. It's exactly the same situation, so they just give you a new question. It says find the approximate, again, keyword. Approximate the average rate at which water is flowing out of the pipe during the 24-hour period. There's a comma, so you should stop at the comma. Don't keep going. They've asked you to do something right to there. The next part is a separate question. That's how FRQs are written. So I don't try to answer two questions at once, one at a time. So I'm ignoring the midpoint sum, just ignore that for now. I'm approximating the average rate at which water flows out of the pipe. So I need to find the average rate. Well, this is already a rate. As I showed you on the previous page, when we made Danica's chart, they're giving you a rate. That's where we're starting. They're asking us to find the average rate. Okay? All of you already know how to find average. Just raise your hand if you know how to find the average of something. Don't overthink it. Just remember what you've already learned. How do you, like not in my class, like years ago, how do you find the average of a set of values? Tristan?
You add them up and divide by how many values they have.
Who knew it? 2 points. Okay. Just add them up, divide by how many you have. Okay, nothing wrong with doing that. That is 100% correct. But on the AP Calculus test, I've never seen them give credit for doing an average using that method. They expect you to do an average using an integral. Okay? So it's just a different method of finding an average. But really, they're equivalent, just two different ways. But to get credit on the AP test, you've got to demonstrate that you understand how to find the average using an integral. Everybody with me? Questions? Awesome. So again, I'm going to write on the board here, and you're welcome to take notes on it to help you understand it. But it's not what you would do on the AP test yet. This is just me explaining the concept. So I need to integrate to find average. So I'm going to integrate R. So I'm trying to find the average value of R. So I'm trying to find the average value of R. I'm going to integrate to do that. So we integrate R. Okay, the reason why integrating, oh, I gotta have the DT though, hold on. The reason why integration can be used to find an average is because think about what happens when you integrate. You multiply, and then you multiply again, then you multiply again, and then you add them up. Okay, so the adding part of finding an average, the integral can take care of that for you. That's why an integral can do what Tristan just said, add things up. We can use the integral to add stuff up. Okay, questions? Awesome. So let's keep going here for a minute then. If we were going to do, again, ignore this for a minute. If we were going to do an integral of this stuff, and let's say we did a left Riemann sum just as an example, then this integral would become, we go to the first subinterval, we take the value of R on the first subinterval, which would be 9.6, and we multiply that by dt. dt means change in time for the first subinterval. Raise your hand if you know what the dt would be in this example as I'm showing you. What would dt be for the example that I'm illustrating? Boston, 3. How many knew it? 0.2 for Boston. Somebody tell me the next term. We're doing the left Riemann sum approximation of the integral. Avery. 2 points for Avery. Someone tell me the next one. Go.
Let's see, 10.8.
Multiplied by
3.
2 points for Isaac. Someone tell me the next one. Please, Rebecca.
11.0 times 3.
Next one. 2 for Rebecca. Let's go here, sir.
11.4 times 3.
Next, 2 for Sarah. Allison.
3 times
Pretty exciting. Oh, my bad, thank you. Someone else?
10.7 times 3.
Elijah, 2 points. Someone else?
10.2 times 3.
2 for Mikkel. Someone else?
9.6 times 3.
2 for Hadley, but we stopped there actually. If we're doing a left Riemann, yeah, no worries. Right, no, you're fine. If we're doing a left Riemann sum, we would stop there. So. Questions, anyone? Please.
Didn't you say we had to have units on at least the first?
Oh, like right here.
Yeah.
You don't have to, but it is a good idea to just check and make sure that the units are working out how you expect. We'll kind of work about through the units at the end on this one, but no, you're correct on that one, 2 points. But it's not required. I told you to do it because I feel like it'll prevent mistakes. Please.
I just can't remember. Why are we doing the 3 on all of them?
Oh, so when you integrate, you're supposed to take a value of r and multiply by dt. dt means difference in time. So for the first subinterval, we start at 0 and go to 3.
Oh, is it because there's 3 between all of them?
Mm-hmm.
Oh.
No, good question. No, it's perfect. 2 points. Anybody else? Please.
Just how come you chose to do a left Riemann sum?
Oh, random. Could have chose right, could have chose midpoint.
Okay.
Didn't really matter.
Okay.
You good at that?
Yeah.
2 points for Trey. Anybody else? Perfect question. Okay, so this is the integral. Look up. This is the approximation of the integral, as Trey said, using a left Riemann sum. Please don't do this. You're not integrating again. This integral gets approximated by doing these series of computations. So don't add an extra integral sign. That's it. Okay? We're trying to use integration to find an average. This is not the average of these values of r. Okay, it's not the average, but I can make it the average by doing a little trick. I'm going to factor out the 3. So write this down. So we take out the 3, and we're left with 9.6. We won't write all of them. It gets a little bit tedious. Plus 10.4, plus ... and the last one would be 10.2. So we just factor out the 3. Okay, not a hard question. I just want to make sure you're thinking with me. In this example, how many different values of r are we adding up? Just raise your hand. It's an easy question. How many different values of r are we adding in here? In this example, how many different values of r are we adding? It's an easy question. Just want to make sure you're thinking with me. Grant, what is it? Somebody knew it? 0.2 for Grant. Okay, so we're adding 8 different values together. That means, following Tristan's comment earlier, to find the average of 8 items, you've got to divide by 8. Well, here's the trick. Once we pull out the 3, Okay? If we simply take the 3 and divide by the width of the time interval. We're finding an average from time 0 to time 24. So the entire time period is, yeah, look. 3 over 24 is the same as 1 over 8. That takes care of the dividing by 8. It's a little weird, but it works really well.
Can you go over that one more time?
Uh-huh. So we're trying to understand why it is possible to use an integral to compute an average. We started with Tristan's comment that average means add up, divide by how many you add together, right? And I told you that's legal, but no points for that on the AP test. You have to show how to use integration to find an average. So I'm doing that. I said, let's integrate what we want to average. We want to average R, so we're going to integrate R. Well, that got us to here, which is looking pretty close to what we need because we're adding together different values of R. But the 3's kind of messing things up. So just factor out the 3. Now I'm closer to what I want. I'm adding up values of R. I added 8 of them. That means I need to divide by 8. Well, conveniently, we simply take the 3 and divide by the entire time period. We get the 8 we want. And that always works. Okay? So we end up with 1 over 8 multiplied by all of the R's added together. That's the average. 8 things added divided by 8. That's how integration can be used to find an average of something. Please.
So when you're doing this, can you, like, at the top you have, like, whatever, the integration and RT. Do you not have to change that because it's not technically an integration? It's average.
Let me say it back to you, Hadley. 2 points. Okay, I didn't have the 1 over 24 initially. I've added it now to make a true statement. It wasn't true before. The average of R is not equal to the integral of R. The average of R is equal to 1 over the time period you're averaging, so 24 minus 0, multiplied by the integral of R. So these two things multiplied together does give me the average of R. So this line here would have to have, all of this multiplied by 1 over 24. Then we factor out the 3, there'd still be a 24 right there. Now we have what we want. Questions? Okay, so that's how the formula works. You do not have to repeat this. Like, I've never seen an AP question where you were expected to understand where this formula comes from. But there are a good number of AP questions that do expect you to have the formula memorized. So, for example, look at that one more time. Yeah. If I'm working this problem, I would say they want me to find the average value of R. So the average of R is going to equal 1 over 24 subtract 0. From 0 to 24, R of t dt. The general formula is this. The average value of any function is simply 1 divided by the width of the average multiplied by the integral of the function itself over that same span. So this needs to be a flashcard. Comments or questions by anyone? The red is the flashcard you must have. Okay, can I erase the red? So in the AP test, I'm trying to find this integral. That got me to this comma. So please add to your notebook this information right here. Put somewhere in your notes this. We are starting to use integration in different ways, and it's really, really important that you keep separate in your head reasons why you would be needing to do an integral, as opposed to how am I supposed to compute the integral.
So we integrate, like, how we actually do it. The Lumerian is just like a approximate, kind of like a, it's not very correct, but the calculator gives us some more, like, correct answer.
Yeah, let me say it back to you, Elijah. So these are reasons why you'd want to do an integral. It's really no different than saying, well, why do we need to add things up? There's lots of reasons why you need to add things together. Well, there's lots of reasons why I would do an integral. We talked about prior to the break how you can use an integral to calculate a particle's change in position, how to calculate where the particle is located using the fundamental theorem of calculus, how to calculate the total distance traveled by the particle. Then the pink packet was how to find area using an integral. Just now we've talked about how to find an average value of something using an integral. Once you figure out, how to create the appropriate integral, you still have to figure out how do I actually compute that integral. And as Elijah just said, the Riemann sum methods are one way of computing the integral. It's just an approximation, but it works. The calculator is a much better way of approximating the integral. Just two different methods. Two for Elijah. Anybody else? Superb. So back here, I'm writing the integral because I need to find the average value of r. So I need to find the integral of r multiplied by 1 over the width of the integral. The second part of the problem dictates how I should actually compute the integral. Midpoint Riemann sum with two subintervals. So I've got to go from 0 to 24 in two subintervals. So that means I go from 0 to 12, and then I go from 12 to 24. So to compute this integral, don't forget the 1 over 24. I'm supposed to take r of t times dt. So I look at the first subinterval, and I pick a value for r that is in the middle of the first subinterval. So someone tell me, what do I write here?
10.8.
What is it?
10.8.
So I go to the middle of the first subinterval, which is 6. The value of r in the middle of the first subinterval is 10.8. 2 for Elijah. Somebody by raise of hand tell me what's the dt that I'm supposed to multiply by. Go, Zach. 12, because the width of the first subinterval is 12. It's another example of how in the AP test they just switch things up to just try and keep you from just memorizing manipulation. They present the table in a different format. Somebody tell me what's the next things that get written. Hands, please. Let's go, Allison.
You go to the integral the next time with dt, so it's 10.7 times 4.
Nicely done. 2 for Allison. Okay, we're finding the please, Brendan.
Sorry, where did so I know when you wrote on the red as a b minus a, where did the 0 come from? Like, when is it not 0?
Oh, gotcha. So if they had said find the average of r for the time period 9 to 21, then I would be integrating from 9 to 21,
Okay.
and I would multiply by 1 over 21 minus 9.
Okay, so the 0 is that.
Does that make sense?
Yeah.
2 points. Anyone else? Okay. This is back to Mikhail's comment. We're trying to find the average of r. So this is the average of these rates. It's not a great average, it's only taking two values, but it's still an average. So what units belong here? Raise your hand, all who know. Checking everybody. What units must I write here to get full credit? I'm finding the average of R. So what units belong here? Finding the average of R. Maddie.
Gallons per hour.
Gallons per hour. The units of R are gallons per hour. So the average value of R would still be some number of gallons per hour. This is full credit on the AP test. You don't need to compute it. Just stop.
Please, so you said that when there's a comma, you do the first problem and the second problem. So is the answer just the second problem?
Good question. 2 points for Elijah. I can't quite remember, but pretty sure that you get 3 points for a question like this. 1 point would be given if you had written this portion correctly. So that's 1 point. That's why I say that's the first part.
Oh, okay.
The second point is if you write this part here correctly. The third point is for the units.
So what we did before was just finding the answer to the top equation.
Absolutely. And it fits right here, Elijah. We were here. We were saying, why do we need to do an integral? So we can find the average value of something. Once we have the integral, how would they like us to compute that integral? Riemann sum. Keep those separate. It's how all AP problems work.
So you do the reasons for integration when you actually compute it.
Correct. And the reason will be different depending on the problem. The method of computation will be different depending on the problem. Keeping them separate is easier on your brain. You just worry about why am I doing the integral first, then I forget about that and just say how do I compute the integral. It's perfect. Hadley?
That whole first thing we did where we had like all the numbers and we were adding them, that was just to explain the 1 over 24 minus 0.
Perfect. Perfect. So all of this was just hoping that you would be comfortable with this formula right here. That's it. So this part here, I don't think I've ever seen this ever be required again. It was just to get you comfortable with the formula. 2 points. Zach?
Is a Riemann sum the only way to do an integral by hand?
The other way that
Be
they'll...
exact.
You're doing great. There are 2 other methods that you'll be expected to use on the AP test. We learned that you can use an integral, and we did it with our calculator, to find areas. That was the pink packet. On the AP test, they'll devise problems that ask you to do the opposite. They'll give you a graph that's all straight lines and such, and say, oh, find the value of the integral. And so you can find the area first, and then say that's the same as the integral's value. So that's another way you'll be asked to do it by hand. Another method we will learn about February. It's a little hard to explain, so we'll just not worry about it for now. But is that your question?
Yeah.
Perfect. Please, Brennan.
Does the calculator or Riemann sum like go to the reason? Like, can you match them? Or is
Say it
there
one more
certain-
time.
Like, is there certain reasons that you do use the calculator and not the Riemann sum?
Oh, gotcha.
Like, do you know what I mean? Like, if you were like to match them.
Not for our class. For our class, I would keep this column completely separate.
Just depending on like what they like. If they give you equations, like, is it easier just to stick it into a calculator? But if they give you just like this graph, it's easier just to do the Riemann sum.
2 more points. Really good question.
How do you? What tells you yes or no?
For our test, for the AP test, they'll just tell you. So they never expect you to try and decide, hey, what method should I use? They just give you only one method.
Okay.
And you just use whatever method they give you. Now, it is true what you said that, I wouldn't even remember it that way. I just followed their instructions.
Okay.
They tell me to do a Riemann sum, I do it. They tell me to use the calculator, I just use the calculator. So they don't usually say use the calculator, it's like the default. If the calculator's allowed, and they don't say do Riemann sum, I'm using the calculators. Does that answer your question?
Yep.
Anybody else? Please.
Wait, so why was this one gallons per hour, but then the other one was hours squared?
So back to Danica's chart. They gave me a rate, that's this. They wanted me to find r prime, which means the derivative of this.
Okay.
So they want me to start here and end up here.
Okay.
So these units had to be gallons per hour per hour.
Then this one wasn't.
Stay with me for a second, Ashlyn. Another reason I know that these units are gallons per hour is because of where the numbers are coming from. 11.4 has units of gallons per hour. 12 has units of hours. So that's why I end up with gallons per hour over hours. The average is a little harder to see, so I think it's a little quicker just to, well, you can do it. This is what Mikhail was saying. Look here. Say out loud, please. What are the units of 9.6? Say it. No, the units of 9.6 are what?
Gallons per hour.
Louder.
Gallons per hour.
Gallons per hour. What are the units of 3? Hours. So this is gallons per hour multiplied by gallons. Ah, shoot. Gallons per hour multiplied by hours. So what are the units of the total thing? What's this? Just gallons. Louder.
Gallons.
Good. Then you divide by 24 at the end. But what are the units of 24?
Hours.
Gallons per hour. One more time. One more time. Look. Take 9.6. What are the units?
Gallons per hour.
Good. What are the units of 3?
Hours.
Multiplied together, you get
Gallons.
gallons alone, right? So this is the number of gallons plus gallons plus gallons plus gallons plus gallons, right? So you get all the gallons, then you divide by hours, you get gallons per hour.
Oh.
That's because it's an average. It's the average of the rate. The rate itself is gallons per hour, so the average of the rate is still gallons per hour. Good work. We need to repeat that. Ashley did that. Okay. Next one. Okay, so, and again, you can stop here on the AP test. Please.
Can you use the calculator to sub this integral?
Not without an equation. Is that what you meant? Good question. 2 points. Next one. Okay, I told you that we're kind of jumping around, trying to integrate, merge different ideas. So this problem does not use anything we've learned today. This problem is simply a review question from what you learned prior to Christmas, but it is presented in a slightly different format, as they always do on the AP test. So everyone work this problem, then we'll just check and see if you got it right. Go. So nothing new to teach you for this problem. You just have to apply what you already know. Stop me if you have a question. Random. Yeah, just random. I think there said f of x dx. It just shows up. Pretty common to kind of switch back and forth between thinking of this as the x-axis and this as the t-axis. board, see, raise your hand if you have this written on your paper. Look at it carefully. Raise your hand if you have this written on your paper. 2 points. They asked me to find the integral using a Riemann approximation. Again, don't do this. Okay, don't ever do that. This integral is not equal to this integral. This integral is found by doing these computations. We're supposed to take f multiplied by dt. So it said 3 subintervals, so I divided up the entire integral into 3 equal subintervals. The first subinterval, the value of f on the right of the first subinterval is 1. So there's the 1. dt for the first subinterval is 6. Just wave if you need me to say that differently. Question, go ahead, please.
I wrote 1 over 15 minus the 83 at the front. That's, we're not taking the average, so I shouldn't have that?
Correct.
Okay.
Very good. 2 points for Maya. Let me just, what she said was a common error, so look, everybody. No, it's what they're trying to trap you. So they didn't say to find the average of f, they just said find the integral of f, because they're related but different. That's all. Good question. Anybody else? Cool. Do you need me to show any more of this? Awesome. Now, if we wanted to find the average, you can throw in the 1 over like you did. So. Okay, next one. Okay, another classic AP technique. They gave you the table. So the table shows different values of R, different rates at which water is leaving this pipe. Then they say the rate of water flow can be approximated by this equation. So what that means is if you type this equation in your calculator and you make a table from 0 to 24, the calculator table will look pretty close to this. This equation is an approximation of this. That's why it's crucial you read slow on the AP test. So they're saying you have the table, but you also have Q. They're the same thing, just different ways of looking at it. So the Danica's chart is no different than what I put on the board earlier. We've got an amount. We've got a rate. We simply can now describe the rate 2 different ways. With R or with Q. So the rate of the rate can be described 2 different ways as well. R prime or Q prime. You don't need me to talk more about that. Okay, it says, use Q to approximate. So we're using Q. Again, this is why you must read slowly. Okay, I've seen many people read quick and they go find the average of this. They don't want you to find the average of this. They want the average of Q. Use Q to approximate the average rate of water flow during the 24-hour period. So we're finding the average of Q, not the average of R. They're both the rate of water flow. Question. Oh, so now you just remember. Average of Q. Let's see, 24-hour period, so that's 1 over 24 subtract 0. The integral from 0 to 24 of Q. Need to have units. Now back to, I think it was Brendan's question. How am I supposed to find this integral? Well, they gave me an equation, and they did not say to use a Riemann sum. It's calculator allowed, so I'm going to use my calculator. So do that on your calculator. Go. Stop me if you have a question. So I was at the meeting. If you want to come at 2:30, I can help you. My preference is to put this equation, Rachel, into y1.
Okay.
Just, I think that's safest.
So you do alpha, trace, and then go over it as well.
This is it. What happened to that?
I'm just kind of.
And just gives you.
Put that in.
I can just take it.
Yeah, I don't know what. You can see that it is working. Yeah, what had happened was that motor set auto instead of decimal. And so it's back as a little fraction that would change that. Sarah, what'd you get?
That's the value I got.
Show me your hands if you got it. Hands up. Come on, let's see how we did. Who got this to work? Who got this to work? So you get 1 point for the decimal and 1 point for the unit. Question? They need me to look at their calculator. Cool, go to the next one. Next one says, what is the average or mean value? Those are the same thing, average and mean value, of that function over that interval. So do that problem, go. Make sure you always write down the integral. Always write whatever integral you're performing, and then you actually do the integral. And always write it. Stop me if you have a question. answer?
See like how that written out there.
How many got it to work? Show me your hand. How many got it? 2 points. Okay, the bell's going to ring in about 30 seconds. So again, the homework is to finish the yellow packets. Good work.